So, question 14. Once again, we're looking at the three scenarios. Worst case scenario, probably what we're going to do. Best case scenario, if we were to stop action and really start helping ourselves. And on the previous page, they talked about our margin of error. And that little bar right there is the margin of error. And the margin of error is quite great. And as you can see, and this is something that you hear in science, currently we're kind of on target to do the same old, same old. So for the first few years, we're going to be doing everything the same. And then right around 2030, everything's going to start splitting up. But question 14 asks to, project the temperature response to greenhouse gas emissions more precisely in the next 25 years. Would it be more helpful to know emissions rates exactly or the exact climate sensitivity? Explain your answer. So which one would be more important? To know exactly what in the climate might get triggered, so what is sensitive in the climate, or what would the future emission rates be on an exact number? What can we really expect? And so the truth is, knowing exactly the rate or the number is probably not as important as the sensitivity. And I know you could argue that it's important to know the number, but to me, the important thing is sort of like, what if you got sick tomorrow? To me, what's important is what's making you sick, not how sick will you continue to get, so that we can stop getting you sick. And so for me, out of these two options, climate sensitivity is the more important thing to know and understand. And that the margin of error anyway is so great currently on our climate modeling that most of the models fit in the projection of error regardless. And so climate sensitivity for me. But if you want to argue the other point, you may. Question 15 asks, how does the magnitude of the projection temperatures respond at the end of the 21st century compared to the temperature increase during the 20th century? So the last century, the temperature has only really increased by 0.8 degrees Celsius. That's what it's really done. And that's just from the previous pages. Like, you can go look at the previous slides and see that. Our future, it depends on the scenario, but even the best case scenario is showing it to, so this is current, right? This is current. It's already increased by 0.8, but even our best case scenario is showing a temperature increase of 2 degrees. And so I guess what I would want to point out is it seems like the conditions are accelerating, right? And so some sentence that explains that you understand that. Some have argued, so 16, some have argued that an average temperature increase exceeding 2 degrees Celsius by the end of the 21st century could lead to irreversible environmental change. Based on the three scenarios presented here, what would be required regarding emissions scenarios or climate sensitivity in order to reach this threshold? So you got to use some logic here. In order to do it, we have to only allow the energy to double. And that's going to happen if we reduce what we're currently doing and then do not exceed it ever again. And so that's only going to happen if, the progression of what we're doing stops and we keep everything status quo. And that's really hard to do because that in some ways says slow progress. But that's what we're talking about. You need to use better information. You need to tell me what that means. Are you cutting car emissions? Are you changing the types of energy that you're getting electricity from? Are you cutting back on industrialization of nations? But talk about that for question 16. You can also go back and reference the previous figure, 17-6, to see those emissions variations. All right, so last question, 17. Internal variability. This is something that's happening on the ground, i.e. the ocean in this case. And we're going to be talking about El Niños and La Niñas. We talked about how El Niños happen during the South American summer, and La Niñas are the little events that happen during the North American summer, so the South American winter. But either way, it's a pooling of water in the Pacific Ocean that cuts back on the conveyor belt, the natural ocean conveyor belt. And it does create natural things in the hemisphere. For example, El Niños create a warming on the South American coast, so depending on where I do it, and it's a natural warming that kind of counts overall because of the amount of land mass that's affected. There's a whole lot of land in South America where it was not affecting, which was the Indian Ocean regions prior to, didn't have a lot of land mass. La Niñas, since it's affecting it during the winter months, creates a natural cooling in the area, and that's because the ocean can store heat, and I'm cutting off on the heat storage ability of the ocean by not moving that warm water across. And so they do matter for those pieces. So down below, they're showing you temperature anomalies. One of them is showing the natural El Niños, and the other one is showing La Niñas. And then they're showing you the temperature anomaly, the actual measured temperature in the solid line, right? So we have our solid line that shows the natural temperature anomaly. Question 17 asks you to provide evidence using the figure below of El Niños and La Niñas and how it influenced global temperatures. Well, in this case, you can just pick some events. So I can pick like a recent event, like this one here, and I can say, in the mid-90s, we had a natural event, and that I can see this spike, and I kind of drew on top of my little spike, but I'm looking at this spike right here. Let me use the highlighter. I can see that there was a natural warming of Earth's temperatures during my El Niño event of the mid-90s, and that the Earth's normal temperature warmed up to 0.5. So that's one event. I can pick a La Niña, and this is a nice one that coincides really nicely, because that meets it really cleanly. And I could pick one here because I could see it really cooled off, and I can see that we had a bunch right here and it cooled off. And so we're just looking at these natural spikes. This was a natural warming spike right here. You can see the natural warming spike that occurred here. So pick dates and use them as evidence, and write some complete sentences. Give me like 2 to 3 examples of La Niñas on this image below, and give me 2 to 3 examples of El Niños on the image below. Be nice and clean on your data. And on that note, you have officially completed Lab 17. I hope that it helped you understand how we are perceiving what the future holds as we begin to tackle the issues of global climate change. Thank you. Bye.